Hello everyone, in this lecture we are going to learn about designing nozzle in PVElite software. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scootoid.thinkific.com.
Now let us try to add one nozzle. Okay. So let us go to the data sheet and find the nozzle. So there are multiple nozzles. We have N1, which is 10-inch nozzle. It's feed inlet and it is with inlet device. So if we talk about N1, where it is located. So you can see it's located on the shell. So might be on the top side. So second shell we can locate. Elevation is not available at this stage. So we can, based on the indication in the datasheet, we can provide that. Okay. So let us make it in this shell. Okay. I'll try to add one nozzle. So you can see I'll select the element and then on that element, I can add one nozzle. So I've selected that. Okay. There are multiple arrangements for a nozzle attachment, starting from with RF pad. This is set in nozzle with RF pad. Okay. Now, do you understand what is set in and set on? So if this is shell and I have a nozzle in this, if going completely inside, it's called set in. Okay. Set on means on the other side, we have provided like this. Nozzle sitting on the shell, that will be called set on. Okay. Now both set on and set in can be with reinforcement. So the green color you can consider as an RF pad. Okay. So you can have without reinforcement, you can have with reinforcement pad. Okay, with RF, without RF pad. So these are the four combination which you see here for nozzle attachment. Set in with reinforcement, set on without reinforcement. The second one here is set in without any reinforcement and set on with reinforcement. So sketch also clarifies what exactly it is. What about this? Which kind of nozzle is this one? Self-reinforced. But if that is self-reinforced, then what about the nozzle which is below that? You have two nozzles. What is top and what is bottom? What is the difference? Yes, the top one is lip type. Why we provide lip type nozzles? Any reason for having lip type nozzle? Full radiography you can do, right? So full penetration weld can be achieved only if you have that lip. Okay. So if we try to draw that, let me just. So this is the nozzle. Okay. It will be connected like this. So it will be having a lip. Okay. So consider this also as a part of nozzle. So it will be having lip so that it can be butt welded with the shell. Okay. So for this kind of nozzle, the reinforcement is also built in the thickness. You don't have to provide a RF pad. Okay. So these are used for very critical applications because definitely they will be costlier. It's a forging from which you'll have to make it. So they are pretty costly. And whenever required, then only you have to use. This one is self-reinforced without any lip. Okay. So that nozzle, if I draw, it will be going like this. Okay. So the hub, which you can see is thicker. The reason for thickness is RF pad. Okay. You want to provide the additional thickness to take care of the reinforcement requirement. Okay. Make sense? In the tip, we also take as SRN type. In tip, I didn't get that. SRN, this also is SRN. Okay, SRN are both, but lip type is having butt welded option, while here you'll be having only groove type. Groove and fillet you can make, but in the previous one you can have complete full penetration in the first one. So it's very costly. Makes sense? So there are different options. Now let us go with the first one. We'll be having a nozzle with RF pad. So let us call it as N1 nozzle because that is what is the name. 106B is there for the material. So that is good enough. The nozzle size was 10 inch, I guess. N1 is 10-inch nozzle. So let us make it as 10 inch. Okay. The dimension will be OD based. Okay. And here you'll have to select minimum thickness. Okay, because you'll have to take care of the under tolerance of that pipe. So we'll be considering minimum thickness, corrosion lines 3 mm. So once you provide this data and you're getting error as area failed and UG45 failed. Okay. What does that mean? What about area failed? Means reinforcement area is not sufficient. What about UG45 failed? Thickness requirement is not meeting. So for increasing the thickness requirement, what we can do? We can change the schedule of the pipe. So let us change that. 120 if I'm taking, both are getting qualified. Okay. So area also and the thickness also. Okay. Because thickness is high, so whatever additional thickness we provide, that will be considered as a reinforcement. Okay. So that is the data for using pipe. So here what I've used as a nozzle, it's a pipe which I've considered. So when I select pipe for a nozzle, I'll be providing schedule because pipes comes in terms of schedule, right? Diameter basis will be always OD, right? Pipe is procured based on outside dimensions. Make sense? Thickness basis will be minimum for using pipe because you'll have under tolerance coming in that. Okay. What if I'm using a plate for making that nozzle? Okay. If my nozzle size is big, let us say my nozzle size is 24 inch. I may select plate also because I can roll and make a nozzle with plate. If the diameter is shorter, it becomes difficult for us to do the forming. So what do you think in this case? If I have a plate, how I'll be providing the data? Let us assume that this 10 mm thick we are making from a plate. Right now, we have selected pipe. That is true. But with pipe, we have provided the dimension. Now, what if I want to make it from plate? How I'll be adding the data? Whether I need to change something or whatever I provided is sufficient. Actual thickness. Okay, so first it will be starting with the change in material. So I'll be using SA516. Then schedule. I will not be selecting any schedule. Okay, size. You can provide actual size or you can take the dimension which is there. Diameter basis will be always ID because now if you're making a cylinder, you'll be using the ID as a dimension. Thickness will be always actual because you will be providing the plate with the actual thickness. So whatever plate thickness I've used, let us say I've used 16 mm. So I'll be providing 16 as a thickness. Make sense? Guys, how I'll be doing for plate? So I'll be using ID, actual thickness. So what exactly you are selecting as a starting material, your dimensions will change based on that. Make sense? If yes, then I'll go back to pipe and we'll try to complete the data for the rest of it. So when I'm selecting pipe, I'll be selecting OD, I'll be selecting the minimum thickness. Okay. 80 is not getting qualified. So 80 thickness is sufficient. So only area is not getting qualified, so that I can take care in this. Okay. I can have 100 mm RF pad. Now that area is getting qualified. Okay. I'll come to that. Okay. So let us start from this point and go down. Then we'll go to RF pad. Okay. So this data is clear. Now I'll be going where I want that nozzle to be. You can change it. Okay, that is a selection. Normally, we make nozzles from pipe, and pipes are available in inches. Okay, and that is the reason we select inch normally. That is the reason. If I want to change it, either I have to select that in the start, or I can change it by using this option. You can see here, this is called list dialog. Okay, detail list. So I'll select that, and then I'll be selecting the data which is here. Okay. So if you want in metric, I'll select metric. Okay. I'll go to the nozzle. Now you see it's coming in mm. Okay. So both options are available. If you want to provide as a plate and want to provide ID, you can select that. Make sense till here? Okay. Now where you want to put that nozzle? Okay, we'll be coming to RF pad also, don't worry. I'll be going like this and then we'll cover the RF pad. So distance, right now we don't have the elevation known. So we can go with any dimensions. Okay. It's 10-inch nozzle, so you have to keep the center away. Okay, so let us take 500. If I add the elevation, if elevation is given, I can directly add here. That will be taking from the base level where we have kept elevation as 0, 0. Layout angle, which angle I want to have. If I want to have at 90 degree, you can change it at 90. Which type of nozzle? So mostly it will be radial, so I can select radial nozzle. What about projection? Okay. Projection depends upon the size of that nozzle. If size of the nozzle is larger, you need little bit higher projection, because the bolting, whatever bolts you'll be providing, the tightening will be difficult if you don't have the projection. Make sense? So for 10-inch nozzles, we can keep 200. Okay. For more than 14-inch, we should go with 250 mm as a projection. You can follow EIL standards for that. There are lots of, even company standards may be there. What is this limits? Diameter and thickness limit. That is the restriction on the reinforcement. As per code, if you want to follow the reinforcement given in code, you don't have to mention anything here. If you want the reinforcement to be calculated by code. If you want to restrict that reinforcement, then you can provide the dimensions. Make sense? Weight, you can calculate also. You can, after calculating, if you are putting, then it will override. Okay. In this case, it's not able to take, because if we take the standard pipe, it will take the weight. Okay. Let me just change back that data in the list to imperial. I'll say okay. Then I'll go back. Okay. So now if I say calculate, it's a standard pipe. So it is calculating the weight. Okay. Now coming to pad. So pad will be of 516 grade 70 material. The pad diameter, the limit of reinforcement is 2 times the opening diameter normally. Okay, you have option in T also, T terms also there is one limitation, but we'll be following 2D. So based on that, 10 inch, so I can go up to 20 inch. Okay. So 10 is nothing but 250, so we can go up to 500. Okay. Now this is the maximum, but if you want to keep, I don't need to keep such high because average you can see area which is available, that is 4624. Okay. While area required is 2852. Okay. So I can reduce it. So I'll give it 300, very less. If I say 400, still very less. Okay. Now I will say 450. So now it is passing. Okay. So pad width, if you want to keep as a normal value, you can change this to 100. Automatically that pad diameter will be calculated. Okay. That you have to decide how much margin for it has to be more than the required area. Okay. How much margin, it will be decided also based on you don't want your nozzle to go on the MAWP. Okay. So we'll see that. Don't worry. So you will be calculating the MAWP of the RF pad also. Okay. So if MAWP is becoming constraint for the vessel, then you'll further increase the reinforcement. Okay. Group pad thickness, group dimensions. Okay. So these are all calculated based on ASME. So just provide a value more than that. That will be sufficient. So this is not required 16. Okay. So now you can see in the red blend flange rating is getting not passing. 150 rating is not sufficient. So I'll be selecting 300. Now it is not red. Okay. So it's passing. It's a weld neck type flange. If you want to change it to something else, you can select all the different types of flange. Okay. If you want to change the material, you can select from here. Okay. If it's not 105. Great. I'll come to the local thicknesses. Okay. Once we add some data, so I'll come to that also. Manway or access opening. Is it a manway? In our case, no, it's not a manway or a access opening. So I'll not select that. It's nozzle, which is for input. Okay. So inlet nozzle. So it will not be having any blind attached. Derating will be required if we have the external data. Okay. That time it will be required. Otherwise, it's not required. Okay. Fatigue calculation. We are not performing fatigue, so not required. Okay. So now if I say okay, you can select the nozzle getting created. Right? This is how you make the nozzle. So now I have provided the input for the nozzle. What if there is external load? Okay, then I'll be going to the second tab, which you can see. It's local stress analysis. Okay, so I'll select that. Now, which calculation I need to perform? WRC 107 or 297? Both options you can see here. Which options I should take for this configuration? 297, right? Or 107? 297 or 107? Why not 107? Or why 297? Any reason for that? 107 is for head, but why? Why for head you have 107? 107 gives stresses in shell only. Attachment it will not give. While 297 will give the stresses in both. Nozzle also, shell also. Now, why 107 we use for head, not 297? So 107, your main vessel can be spherical or cylindrical. Both options are available for 107. But 297 is limited to cylinder connection. Okay. So that is the reason on head you cannot apply 297, and that is the reason you use 107 for that. Okay. So in this case, definitely we'll be using 297. Okay. Now, if the loads are given based on project specification, you can take. If not, you can take some standard loads also. Okay. So you can take like EN user loading. So you can take that as a loading. Okay. So this will be random. Okay. If it is available, you can take that also. Making sense? So this is the loadings you provide. You have to be careful with the directions. Whenever you are comparing the direction, in the input also, the direction has to be indicated. Okay. So input match with the output. So once I provided the data, okay, you can see there is a stress calculations happening. So you have stresses coming at vessel at nozzle edge, which is 0.3. At pad edge, it's 0.85. And in nozzle, 0.356. These are the stresses that are coming. So all are getting qualified. Let me now increase something. Let me increase the ml. Increase by 10 times. Now in the nozzle at vessel, the stresses are exceeding. Okay. If I increase this longitudinal moment, what will be required to take care of this? What will be the solution if your stress in nozzle is exceeding? How you can take care of that, or how you can reduce that? When I increase the longitudinal moment by 10 times, it is exceeding. So increase the thickness, right? That is the option. See, I'm not sure whether, in this case, we'll be able to qualify or not. I have randomly increased the load 10 times. It's gone down. Okay. If I change further, I'll using 860. Definitely it will come down to 0.6. Okay. So like that, you'll see which stress is exceeding, and based on that, you can satisfy or change that input. Okay. What if the vessel at pad edge is increasing in the stress? Let me increase this value, increase 10 times. Now vessel at pad edge is having higher stresses. How to take care of that? Increase diameter of pad, right? Because if you increase the area, the stresses will go down. So instead of 100, okay, I'll take 150. Now you see that also got down. Okay. So that is what we can keep on doing depending upon which stress is increasing. Okay. Now if the stress is increasing in the shell, okay, this one vessel at the nozzle edge, then what if that is increasing? Let me just change. I don't know which one will give you an MC if I change. But let us make this as 5 times. All are increasing. So that is too much value. Let me just change it to 2. Further. If I increase this one to 2.5, still others are failing before. So if I change it to 200, Now I cannot increase this further. So I don't have option in controlling the last one. Okay. Still that vessel to nozzle edge is not exceeding. Okay. Let us increase the value further 2 times. Now it is exceeding. Forget about the others. Okay. It was not exceeding. So we had to increase the value a lot. But now how to take care of this? If vessel to at pad edge is increasing, the only option which we'll have is to increase the local shell thickness. Either I have to increase the complete shell thickness, but that will be really costly affair because the complete weight of the equipment will change. So instead of that, we can use the insert plate. Okay. So using the insert plate, you can just increase the thickness. So I'll change it to 20 mm. Okay. Now if you see, the stress has gone down. Make sense? Yes. So that is how you take care of all these stresses you can control, but there is a limit to control, right? You cannot control a load which is much higher. So at some point you may have to say that, okay, this is the maximum load. My vessel will not be able to take more load than this. Make sense? Guys? Is it making sense? Yeah. How to apply the thrust or when to apply, include the pressure thrust. Whenever you are having a blind attached to a nozzle, that times you have to apply the pressure thrust also, because at the end there is a pressure which is acting on that blind, and because of that there will be additional load coming on the nozzle. So that time you can include the thrust also, okay, which will be coming at the blind which is attached. Okay, but not required all the time. But if you want to check, you can do that. Okay. So that is how we consider. We'll change this value so that we don't have other problems. Okay, local thickness also I'll change it to 0. If I'm changing 0 means it will take the normal values. Vessel to pad edge is still higher. Let me change. Okay. Yeah, when to give global. Okay. So global, when you're using 297, this option is not for 107. It is not available. If I select 107, you can have global. I think for 297 it is not available. Yeah, for 297 that global option is not available at all. Now why we use global option? Global is to match the orientation of nozzle and your equipment. You can see your equipment is having XYZ in this direction. So if you want to apply the load in the same direction with the reference to the actual equipment, then you can use the global option. But that option is anyway for 297, it's not available. Only for 107 you can use. Make sense? Local you can use always for both of them. So, and input also you'll be having most of the time as local. They'll be indicating nozzle, and with respect to nozzle, that coordinates will be given and the load also will be given. Make sense? So now we have created a nozzle. We have applied the load also. But if I'm applying the load, I need to derate the flange. Okay. Once I derate, you can see the flange rating has exceeded. So even 300 may not be sufficient. So I'll have to increase the rating to 400. Okay. Now that nozzle is complete with the external load.
For in-depth training and to learn more about these courses, register with the link in the description.